So this new chapter is mainly going to be about parallelograms. And again, you're going to watch me bring in a whole bunch of stuff from earlier on in the year when I talk about this here. First off, you'll notice that this word quadrilateral. Quadrilaterals are general word for when a thing has 4 sides. Just like triangle was a general word for when we had 3 sides, and then we had more specific kinds of triangles. We had isosceles triangles, right triangles, equilateral, but they all were under the umbrella of triangle when it has 3 sides. All these shapes we're going to talk about are going to fall under the umbrella of quadrilateral, having 4 sides. But then we are going to have more specific types of quadrilaterals, more specific types of 4-sided shapes. And the specific one we're mainly going to focus on this week is called a parallelogram. So first off, our definition. Quadrilateral is a parallelogram if and only if. Again, bringing back stuff from earlier on in the year. That's an if and only if statement, which remember was called a biconditional statement. And it meant that the original statement and the converse, the switch around statement, were both true. So this is what makes something a parallelogram. We have a parallelogram if and only if both pairs of opposite sides are parallel. It's got to be both of them. If it's not both of them, then we call it something different. So we have our first pair of opposite sides being parallel, which is P to Q and R to S. They're parallel to each other. Notice the arrows that are there. And then we have pair of sides number 2, P to S and Q to R, being parallel as well. And the nice thing that this is going to give us is it's going to give us a whole bunch of different properties that are true. So we're going to write down here, we're going to write down all these different properties that are true. And they follow from these sides and angles being parallel. So these are actually going to be true because of things that we've talked about last chapter, because last chapter was all about parallel lines. So these aren't just things that I'm pulling out of nowhere that we're about to talk about. We can actually prove these based on what we talked about last chapter. So that's what you're going to see here. But I'll only prove one of them, just for the sake of time. But note, just keep in mind that you can prove all of these other ones as well. So property number 1. Property number 1 is that both pairs of opposite sides are congruent. Why do both pairs of opposite sides have to be congruent? I talked about how parallel and congruent don't mean the same thing. Just because one is true doesn't mean the other is true. However, in this case, they are both going to be true. Here's how I can prove that. So I know it's a parallelogram, which means that we have parallel sides. Again, I'm just going to prove this first one. But just keep in mind, I can prove all these other ones. What I'm going to do is I'm going to take this 4-sided shape and I'm going to cut it down the middle. And now we have 2 triangles. And we can actually use what we talked about in the last chapter to prove these triangles congruent. First of all, hopefully you all recognize that we have this side is going to be congruent to itself. That's the reflexive property. It's a common side in both this triangle and this triangle. But then let's take a look at what these parallel lines give us. Here's parallel lines number 1. And then I'm cutting this down the middle. And you should recognize those kind of angles. Inside or outside? Inside, and then one's above and one's below. Those are alternate interior angles. And alternate interior angles we know are congruent to each other. So there's a pair of angles being congruent, and I can do the same thing in the other parallel lines. And again, you can write this all out in a proof. I'm not going to for the sake of time, but we could write this all out in a proof. There's the parallel lines, same transversal cutting it down, and once again we have alternate interior angles here and here. So on these triangles, we have two angles, side included between them, and so these are congruent by angle, side, angle. So then we would be able to go from there and say that by CPCTC, all my sides and all my angles have to match up, which will give me this property and the next property. First of all, that these sides have to match up, and also that the angles are going to match up as well. So just keep that in mind as we go forward, that I could use triangles and cutting diagonals and parallel lines to prove all of these properties that I'm about to show you. So opposite sides are congruent. The sides across from each other have to be the same. Next property, the opposite angles are congruent. And again, we can prove this the same way we just proved the last one, with those congruent triangles. My opposite angles are congruent. When I say opposite angles, I mean the angles that are on complete opposite ends of my parallelogram. So if I'm standing at one corner, the angle opposite it would be the angle that's the farthest corner away, all the way over here. Q and S are the same. And then same thing here. When I say opposite angles, I mean I'm standing at P all the way at the other end of the parallelogram. Farthest away is the opposite angle of R. So those have to be the same. So those are opposite angles, and that's as opposed to our next one, which are consecutive angles. Consecutive angles are the angles that are back to back in my shape. So if a quadrilateral is a parallelogram, then the consecutive interior angles are supplementary. And again, this should be clear. This should be something that you remember us talking about from last chapter. Here's this pair of lines. It has to be parallel. And then here's my two angles that are back to back there. Notice the C shape, consecutive interior angles. And we talked about how consecutive interior angles are supplementary. So that one's really easy to prove it being true. So you'll notice that I have these both being X. That's because they're opposite angles, so they should be the same. These both being Y, they're opposite angles. They should be the same. But then the ones that are back to back, anytime I have X and then Y, X and then Y, X and then Y, those are going to be supplementary because they're consecutive interior angles. Those are going to add to 180. So make sure you're careful in spotting those. One thing I want to note here about quadrilaterals, there's 180 between these two and 180 between these two. And I also saw that I can split those, my shape into two separate triangles. And I already know what the angles in a triangle add to. The angles in a triangle add to what? 180. So if this shape is made up of two triangles that each add to 180, what's the entire shape going to add to? It's going to double it and add to 360. So just a note here that in a quadrilateral, in a four-sided shape, the angles add to 360 degrees, as opposed to my triangles where the angles added to 180. So if I add all four angles in this shape together, they should add to 360 degrees. Last property. The last property is that the diagonals bisect each other. Diagonals bisect each other. Again, you should remember what your definition of bisect is. Bisect means split in half. And when I say diagonals, I mean going from one corner to the other. That side that goes from one corner to the other. So here's diagonal number one. Those angles have to be the same, or those sides have to be the same. We're splitting that into two equal pieces. That's this statement. And the other diagonal is also bisected. That's what I mean by bisect each other. They're both getting bisected. They're both getting cut in half, which means that M is the midpoint of both of them. So not only is my red diagonal cut into two equal pieces, my blue diagonal is also cut into two equal pieces. So those are my different properties of a parallelogram. We have our definition, which is that both pairs of opposite sides are parallel. We have both pairs of opposite sides being congruent, the opposite angles being congruent, consecutive angles are supplementary, diagonals bisect each other. So we're going to do something similar to what we did last chapter, which is we're going to say what is true about the thing, and then we're going to use that fact to make our equation. So we're going to write down which of these properties that we're using to make our equation, and then we're going to set up an equation based on that being true about it. So, first one. Given the figure is a parallelogram, find the values of the variables in the diagram, justify your answer. So again, justify your answer means which of these are you using? So let's take a look. Let's start by solving for A. So we have this here, and we have this here. First off, we're talking about sides or angles. Angles, we know that because they're inside my parallelogram and they have the degree symbol on them. Are they on opposite corners of each other, or are they back to back in there? They're back to back. So those are consecutive angles. And we know that consecutive angles need to be supplementary. And that gives us our equation. If they're supposed to be supplementary, then that means that I'm supposed to add them and get what? 180, because that's what supplementary means. So that should be my equation. Again, all the equations that we make are backed up by the geometry. The geometry idea here is that these angles should be supplementary. So that means the equation we make is that we're going to add them to 180, because that's what supplementary means. What are my angles? There's 7a minus 3 and 106. Those are my two angles. So then we're going to solve. 7a minus 3 plus 106. So that's going to be, we're going to combine these together since they're on the same side. That's going to be 103. I won't solve all of these step by step, but this is the first one, so we'll go through it in detail here. So this is plus 103, so I'm going to get rid of that by subtracting from both sides. Get rid of addition with subtraction. This is 77. So then we are going to take the 7a and the 77. 7a is 7 times a, so we're going to get rid of that multiplying by dividing to get a equaling 11. Again, you can plug it in. That would make this angle 7 times 11 is 77 minus 3 is 74. So this angle is 74 added to 106, you get 180. That's what we said should happen. All right, now we're going to use the same angle, but this time, here's 106, but this time we're going to look at this angle over here, the 9b minus 2. We're going to use it to solve for b. Are those angles consecutive angles or opposite angles? This time they're opposite angles. And opposite angles, what did we say about those? What should be true about them? They should be congruent. So because those opposite angles are supposed to be congruent, my equation is going to be to make them equal. (9b minus 2 and 106, we're going to make them equal to each other. I'll give you 30 seconds to solve that. 30-second head start there. All right, I'm skipping down to this one. Because if you want to start on it, I'm going to be asking you to do that next one on your own, to give that a try on your own. But we're going to do this one together. All right. The property that we're looking at. Notice this time we're looking at sides. It's pointing at the sides. It's not pointing at angles. It's not giving degrees. We're looking at sides. And the sides that we're looking at is not the sides in the parallelogram. It's the what? It's my diagonals. Right, here's diagonal number 1. And then here's diagonal number 2. Those are my two diagonals. Go from corner to corner in my parallelogram. Those are my diagonals. And what should be true about the diagonals? The diagonals need to bisect each other, which means that they need to split each other into 2 equal pieces. So if I'm looking at diagonal number 1, it's getting bisected. So these pieces have to be the same. There's my equation. My equation is take those pieces and make them equal. We have 3r plus 13. We have 9r minus 17. And we're going to be making them equal to each other. Again, I'm going to give a little more detail here because this one's a step up in equation solving here. Mostly because the variable's on different sides. So that means that before we do anything else, let's get the r's on the same side. So we're going to take away 3r from this side. 13 here. 9r minus 3r is 6r minus 17. And then we're going to add to get rid of the subtracting. So hopefully it should be pretty straightforward from here. 13 and 17 is 30. 6r is 6 times r. So we're going to get rid of that by dividing. And 30 divided by 6 is going to be 5. Meanwhile, on the other pair of diagonals, here's my other diagonals. They're also going to bisect each other. So they're also going to split each other into 2 equal pieces. So I'm also going to take the pieces of this and set them equal to each other. So I have 7s minus 24, and I have 4s minus 3, and I'm going to set them equal to each other. Again, I want to get everything with s on the same side. So my first step would be subtracting 4s from both sides. But this one I won't go through in detail. But you should get 7. You should get 3s equaling 21. Divide, you get s equals 7. And just a reminder, you can plug these in and make sure that you're getting what you're supposed to get. If I plug 7 in here, 4s minus 3, that's going to be 28 minus 3 is 25. Over here, I get 7 times 7 is 49 minus 24 is also 25. So we get them being the same, which is what we said should happen. Take a minute and try this one. I at least want you, in this next minute or two, I at least want you to get to the point of writing down which property you're using and getting your equation set up. To solve for C, those are opposite sides. I know they're sides because they're not labeled in degrees, and they're labeled outside of the shape. So those are opposite sides. Opposite sides should be congruent, so we make them equal to each other. To solve for D, those are labeled where the angles are, so those are opposite angles. Right? These are opposite angles going from one corner to the other, and they should be the same as well. So we're also going to make those equal to each other. Solve down, we get 9. But remember to write down which property we're using, which equation does that mean we're going to set up.